The evolution of an idea. So available in the 1800s was a bunch of evidence. First one we're going to look at is fossils. So fossils are preserved organisms found in sedimentary rock, specifically sedimentary. And this is where the dead organism is buried, and they're going to have to sit there and then get covered over with sedimentary. It's going to happen without oxygen, otherwise they would decompose completely. And this can cause a process of fossilization. It's pretty hard to have all of the circumstances correct so that the organism's there and then it gets buried and it doesn't decompose, it doesn't get all broken up or eaten or something like that. And so this does not happen very often. So our fossil record is very incomplete compared to how many animals have actually been around. So at the time in the 1800s, some people thought that fossils weren't that old. They thought they were just like, there's like when you find bones buried somewhere, they're like that. But looking at the evidence, they eventually pieced together that these things were a lot older than was led to be believed at the time. Some of the evidence that went towards that was that some of the fossils were unknown organisms, so they'd see things in the fossil record that were not around anymore, which if you don't know all the animals that are around, that's sort of understanding that they may think that, but as they sort of saw and categorized lots of the animals that were still alive and saw that these fossil organisms were not like those ones, though there were some similarities, that was some evidence to suggest that the fossils themselves were older than what animals are around now. There are or at least very few fossils of living species. And so if you look at the animals that are alive and you look at the fossils and say, okay, well, these have some similarities, but they're not the same thing. We don't see fossilized evidence of, say, like dogs or something like that. What we see instead is other types of animals that have been fossilized. And they are, in some cases, buried quite deep, where they have lots of layers on top of them. The exception to that would be where there has been some sort of geographic disturbance where those lower layers have then come to the surface, which does happen fairly often. And these fossils were in unexpected locations, things like seeing sea life found up in mountains where there was no longer any sea anywhere near around, but at some point, maybe a long time ago, there could have been a sea in that area, or perhaps the ground where the sea was has moved up to that area. So the fossil layers, what they'd see is that you'd have the oldest looking fossils, or say simpler organisms, were found lower down, and then more complex organisms were found higher and higher up in the sedimentary layers. And so the more complex things were found near the top, and the more simple organisms were found near the bottom in certain situations. And so looking at this, they're saying, okay, well, if we go back far enough, it looks like these simpler organisms aren't like some of the ones that are around today. The top layers look more like the organisms that are around today. So suggesting that the vertical placement of the fossil was also related to the time in which that fossil was laid down. And again, simple organisms on the bottom, more complex on top, reflecting that it looks like these layers were laid down. I should start at the bottom here. First layer laid down, next layer on top, and so on and so on and so on. And then here we are today, digging through all this stuff, looking basically through time, the deeper we go. Using that fossil evidence, along with a bunch of other things, there was a bunch of figures that were around at the time and leading up to the time of Charles Darwin that helped to influence his thinking. One of these guys was Buffon. He was sort of one of the people to start proposing that maybe things are not as they always have been. So it was believed that species or animals were immutable, in that they could not be changed. They are the way they are. That's how they've always been, and that's how they will be. So what Buffon said was that maybe that's not the case. And he looked at things like these toes that, say, animals like pigs have, and they don't touch the ground. So why would you have toes that don't even touch the ground when you're standing on them? And so looking at structures like that, he'd say, okay, well, maybe they were different, and now over time they have changed. The idea that they are mutable was his contribution to this field of what eventually became evolutionary biology. Then these guys, we've heard of him before, Carl Linnaeus, and another guy, Darwin's grandfather, Erasmus Darwin. They proposed that organisms do change over time. The problem is this is science, and without an explanation, without strong evidence, just saying something happens isn't enough. These guys get mentioned because they're known for other things like classification and being Charles Darwin's grandfather, but really the idea that things can change over time was starting to take hold. James Hutton was one of the guys who provided the framework where we could actually put some sense into the idea of evolution, because around the time that he was doing his thing, people thought the Earth was like a few thousand years old, which if that's the case, then evolution can't happen. So what he was saying is that maybe instead of being a couple thousand years old, maybe the Earth itself is millions of years old. And what's been happening is that it has been changing very slowly. And the idea that what is happening now is what has always been happening. So it is as it was. So there hasn't been these massive changes over time, or sorry, massive changes all at once in the past, and now we're just in a period of calm. But instead, what is happening now is the same thing that's been happening for a very long period of time. So something like a canyon being carved out. It wasn't all of a sudden one big move and it moved all the dirt in one go. Instead, it's just little by little by little by little over a really, really long period of time, we get things like Grand Canyons being carved out. Then we have this guy, Lamarck, and so he was starting to put together the actual implication for living things. And so, really long name, we'll just go by Lamarck, student of Buffon. But he essentially published a theory of evolution in 1809, which was right when Charles Darwin was starting his thing of living. He was the first one to propose a mechanism of change, and so actually trying to explain how an animal can go about being one way and ending up in another way. So he believed evolution was driven by an innate tendency towards greater and greater complexity. So that was like the nature of animal things, is that they move towards this idea of complexity. And so his three concepts that were covered in that are part of Lamarckian evolution, which is not what we're thinking anymore. But at the time, Lamarckian evolution was saying that there's this theory of need where a trait appears as the need arises for that trait. And so another way of saying this is habit modifies form, or essentially if you need something, then your physical adaptations will change to meet that need. He also had the theory of use and disuse, that if a structure is used, then it will become stronger or more prominent or better at what it's doing. And if it's disused, it'll become weaker and smaller. And that kind of gets at the idea of those pig hooves that don't touch the ground. It's like, well, maybe they're not using them, so they're becoming smaller. And then finally, okay, if these things are happening, that's great, but they have to be inherited into the next generation, or it wouldn't have any overall lasting effect. So if we want to look at how we get a really long neck on a giraffe, what we can say is, well, maybe they started off with short necks and they're trying to eat some plants that are up high, so they're like reaching and stretching, trying to get those. And so as they use this neck more and more to try to reach these leaves over a long period of time, their necks actually get longer. So they're trying to reach up and get things, and so they try reaching them, they try using that neck, and their neck ends up getting longer as a process, that the idea that their body is modified by the needs that they place on it. So Lamarck's giraffe stretches its neck for leaves, it grows gradually longer, its offspring then inherit this longer neck. So what we see here is this theory of need, is that they're going for these leaves. They are using their neck to reach the leaves, and so that's our theory of use and disuse. And then this trait can be passed on their offspring, so that's the three main points of Lamarckian's theory. So eventually the giraffes get what they need, the long neck, over a period of time. So some weaknesses to this theory and why we do not teach Lamarckian evolution is that many features don't do this. And so we can see, okay, well, maybe some do, but if you sit and squint at something long enough, you don't get better vision at it. So just because you're using a particular trait doesn't mean that it's going to develop and you're going to be better at it, or it's going to be better at doing what you're asking it to do. This idea of need driving change is not what reality shows us. these acquired characteristics. So even if you do some things, because you may say, okay, hold on a second, if I lift weights all day long, all of a sudden I have bigger muscles. Sure, that is true for some things, but even with that, these acquired characteristics do not end up changing the DNA. So if an individual works out a whole bunch and gets a whole bunch of muscles, that does not mean that these traits get passed on to their children. One little caveat on this is as we get into more and more of epigenetics, looking at how your environment can cause some modifications to your DNA, that we do actually have some changes that can be actually passed on. It's just they're not always, generally they're bad things too. So Lamarck's theory did have some strength with it that we should recognize, and one is, again, just getting the idea that species can change. That was a big win. They also are doing this change, or they are able to change. So one is that they do change, and the other one is that this change is brought about by the environment. So those are both correct, and that these changes can be inherited, also correct. So the Lamarckian theory had some weaknesses and had some strengths. Another person involved in thought at the time was Malthus, and essentially he was looking at numbers, and so this allowed Darwin to sort of see how the numbers can work in terms of driving this process. But if a growing population will eventually run out of resources, so if you have your population going up, your resources, even if they are going up, eventually, if your population is going up faster, you're going to run out of resources. So this leads to a struggle for survival, and this can essentially exert a pressure on the population. And so if we have this, and so again, he's looking at this with regards to humans and all that, but Darwin was able to take this idea and say, okay, if there is this pressure on the organisms, then perhaps there's going to be this cause for change based on the environment that they are in. Another person involved with this, a paleontologist, Gradual, believed that species did not change at all, and so sort of a counteraction to this idea was the general idea that the environment that we see around us, so the mountains and the canyons and the valleys, was shaped suddenly by short extreme events. So this is what they were arguing against. And again, if you only have a few thousand years to create everything that is around, and you're trying to explain the geology that was around, this is what Gradual was saying, is they said, okay, well, this must be catastrophism that went along. So there were these huge events a while ago somehow that would have created these really big changes, things like floods wiping out entire regions, and this could explain what we're seeing in the sedimentary layers, that we see all these dead animals in one particular level. There must have been some giant catastrophe that wiped them all out, and then there's some new group created for the next layer, and that's what we're seeing when we see the fossil layer. So this was George Cuvier, and he was sort of suggesting that's what we're seeing with the evidence. Luckily, Charles Lyell, a geologist, apparently a lawyer as well, he was working on what Hutton was saying earlier and saying, okay, well, as a counteraction to this catastrophism, instead of these things happening very quickly all at once over a short period of time, let's think about them happening gradually, or more again, that the Earth is how it is now is the same as it has always been changing. It is as it always been. So that it changes very slowly over time. If you have a river slowly winding through a river valley, it'll move grains of sand at a time. And what this again allows, if this uniformitarianism is correct as opposed to the catastrophism, what this allows for is a huge amount of time for the Earth to be around, and that is what is necessary for Darwin's theory to make any sense at all, is that these changes have to be slow, and they have the same laws that brought about them, whatever the changes are, like raising mountains, is the same thing that's happening today. And the big point is that if Lyell's correct, and we same thing with Hutton, if these changes are happening as they are happening now, as they always have been, then they must be very slow, and this means that Earth is extremely old. There's a bit of a contrast between the idea of catastrophism, which we are going to say that is not how it's happening, versus uniformitarianism. And there we go. Jasper's fun. Uniformitarianism.